everyone, welcome to Electronics Techie. So in this video we are going to design the 8 to 3 encoder. So how we are going to design the 8 to 3 encoder is nothing but, so it has 8 inputs and whereas 3 outputs. So it's like a reverse operation of decoder. So if you don't know about the encoder operation, just comment if you don't know about that. So I make separate video what is the encoder, what is the process, like that. So in this video just how to design encoder, that is only going to be discussed here. So if you have any doubt about encoder, so you can comment on it. I make a separate video. So until now, according to the time management, I just only discuss about the design of the encoder only. So that is also 8x3 encoder. So I directly do the code in Vivado, so instead of using PPT like that. So by that you also know the what is the color changement and what like that. You also are familiar about this Vivado tool. So I use Vivado tool here. So first we have to do the code here. So for that I have to take the input. So what is our input? So for that we simply write the input keyword. So what are our inputs? So there is only 8 inputs. So by using one variable you are going to define the 8 pins. So how you are going to define? By using the vector format. So 7 down to 0. So nothing but, so they are the 8 pins. So those are the inputs. So that's why I simply write in. So what is our output? So we have 3 outputs. So that's why I represent in vector format 2 down to 0. That means 2, 1 and the 0. So for that is equal to out. So from that you can close the braces. So next what you are going to do? So complete the input and output. So next we are going to do the always at the rate sensitivity list. So why you are going to write the sensitivity list? Means we all know about the sensitivity list concept. So what is the star? It represents the sensitivity list. Means if any single bit change in the input also, this block is going to be executed. If there is no change in the input, then this always block is not going to be executed. So we all know about when we are going to use the always block, what are the variables we are using in that always block? It should be a reg data type. So that's why I mentioned it as a reg data type. I think you all understand what is the reg data type. Because of always block we are using out variable in the always block, that why you are going to use the reg data type at the output pin. So that's why I mentioned out variable as a reg data type. So now what you are going to do? So there is a multiple line, so you start with begin. When there is a multiple statement, you are starting begin and end. So inside these begin and end you are going to be write the code what you are want. So begin. So after that what you are going to do? So if encoder according to our pin selection, means according to our if there are the 8 pins. So if what are the pin value is going to be 1, according to that the combination of the output will going to be same. So like that, if I of 7, your MSB bit will be going to be 0 means, so equal to 1. So if I of 7 value is going to be 1 means, so what is our output? So output combination is nothing but 3 to 3. So they are the 3 bits. So that's why we represent with 3 and binary tick, and binary means B. So they are the 3 ones. So your output will be 3 ones. So else, so it is not the case. If your I of and in of 7 is not equal to 1, so then what happened? Then it's going to check if in of 7 is equal to, if I of 6 equal to 1. So then what is going to be done? It is closes like this. So your out will assign to the 3 tick B 6. So in binary you represent 6 with 1 1 0. So our output is like 1 1 0. So end with semicolon. So like that you are going to write all the cases what you have. So what are the cases we have? So else, if another output is like, so your in of 5 is going to be 1. So then our out is going to be assigned as 1. It is a 3 bit. So that's why 3 tick B 1 0 1. So else, so it is also not the case. So then in of 4 equal to 1. So what you are going to do? So our out is equal to 3 tick B. So our 4 value is nothing but 1 0 0 and end with semicolon. It is also not the case if else. So in of 3 is equal to 1. So then our out is going to be 3 tick B 0 1 1. I simply write the decimal equivalent value here. I think you all understand about that. So if else, so if of 2 equal to 1, so then what is going to be done? So our out variable is going to assign 3 tick B 0 1 0. Else if in of 1 is going to be 1, so then our out variable is going to be assigned as 3 tick B. So what is 1 means 0 0 1. So else it is also not the case. So else if, so it is only the another case is only 0. So you simply write else. So no need to write if else. So out is equal to 3 tick B 0 0 0. So and it is closed, and end. Begin will end with end keyword. We already written here, so no need to write. So this is the complete. So you have to see the here is a green color tick mark. So here you can see the arrow mark of mine. So there is a green color square box. It means the your code is like proper way. So if it seems like red, so if you see I remove the semicolon here, so it simply represent with red color. So you mean some error. So it represent here. So see, so like that we will be cross check whether your code is going to be run. A simple error is going to be shown here. According to green, you can simply understand, okay, your code is going correct in a correct way, proper way, like that. So here you can save here, and then after what you are going to do, so I am going to create a test bench. So create new file and simulation. So it may be not visible to you, so no need about that. So no problem. If you want how to use the Vivado, then comment on it. I will explain how to use the Vivado. So wait, I am creating test bench here. So Vivado is like a free tool, a free source, so it is very simple to access. So it's not much difficult. So if you don't know about that, if you want to know, so you can say that. I will make a video so about that. So you must know that whatever the module we are going to be run, so it should be top. So here you can see there is a symbol like top symbol. So according to that, we have to make set as a top. So every time we are going to be set as a top. So wait, I am opening my test bench. So it is our test bench which seems here. So it is very simple. We all know about the test bench syntax. So it is very simple. What are the inputs? It should be reg data type. So what is our inputs? 7 down to 0 in. So semicolon while. So what is our output? 2 down to 0 out. So it is our input and output. You simply represent inputs are with reg data type, output with y data type. So now what you are going to do? So whatever design module is going to be, instanced in the test bench code. By using this line only, these two codes are going to be connected. So what you are going to do, so means whatever the design code module you have written here, so you can make any instance name. You can write your name also. DUT means design under test. It is a standard one you are using in the Verilog. So DUT after you are going to connect the port connection. So the other two variables you are connecting by order. So after that we are going to start with initial begin. In this we are going to give different combination of input. So initial begin. So in that file I give input as, so they are the 8 pins. So that's why B. So 0 0 0 underscore means for every 4 bits you are using any. So I given like this. So after some delay I give another combination of input. So 8 tick B. So you can take 1 0 0 underscore 0 0 0. So I take 2 combinations only. If you want, you can take more combination also. According to the time management, I take only 2 to cross check whether my code is correct or not. So I end here. So this is the test bench code. It is very simple. Inputs with reg data type, outputs with y data type. You have to instance the design code module in the test bench code, and initial begin, give some combinations, and end with your simulation with finish. So then we simply save this here and run the simulation. We are going to run the code here. So after this process you are getting the waveform. So according to your waveform you are cross check whether your code is going to be correct or not. So it is going to be run. It takes some time maybe. So just wait how it is going to be done. So if you have any your truth table and your design is different with your waveform, there is some mistake. If you don't get any error also no problem, but there is some syntax syntax problem is not there, but there is some what you are going to say, that means logic problem. So maybe some logic is going to be mistake here. So once cross check, so no problem at all. So see, so I am going to expand this. So see here, our in of 1 is going to be 1. So our output is going to be how you will get 0 0 1. So see 0 0 1. So another combination. So I give in of 7 value is going to be 1. So see here, see in the code, in of 7 is going to be 1 means, so what is our output? So all are 1s. So cross check whether our output are going to be 1. So see here, all the outputs are be 1. So that means 7. So it is about waveform. So by this waveform I say that okay, my code is correct. So whatever I done, whatever I designed, so it will be correct. So if you get any errors, if you have any problem according to run this code, so you have any line if you don't understand, so you can simply comment on it. So now you are going to be show the schematic diagram, so you can see how the schematic is going to be done. So whenever you are going to understand your schematic, it is similar to your hardware, real hardware. So it may be some give the hardware knowledge to you. So just wait some time, so it will be loading. So it takes some few minutes. So until then we can discuss about this encoder. So encoder is nothing but is a combinational circuit which have 8 inputs and 3 outputs. So not only 8 and 3, here only we discuss about 8 and 3. So we have some other also we have some, means they are the 2 power n inputs, so they are the n outputs. So 2 power 3, so that is by 8 inputs, so 3 outputs. So like that, 2 power n inputs and n outputs. According to that we can design. So there is a 4 inputs, there is a 2 outputs. 2 square is nothing but our input, so 2 is our output. So like that we are going. So see, our schematic diagram is going to be look like this. So there is a input and here is our output. So there is a 8 inputs and 2 outputs. So this is our design code and this is our test bench code and waveform and schematic. So up to now it's all about clear. If you want any combination, means there is a 4:2 and other 16:4 means 16:4 encoder. There is a so many combinations. Try those all also same. According to your tutorial, simply use this if and else statements. You simply write the code. If you have doubt, and you can say that in comment section. So everything will be going to done. I directly do this code in Vivado. If you are any misunderstanding about this code, so you can say that. Again I try to make it as in a PPT by using pen, so it may be more clear. So thanks for watching. If you have any doubts, you can comment on it, and thanks for your support and all your love, and thank you. Bye.